Take a look at that puppy right there in the middle of the screen. He's just sitting there. We have no idea where he is. So that's why we need to talk about position. So to make this simpler, I'm going to put like a number line down. Oh, hey there. So let's put our number line down. Okay. But you don't really see any numbers yet, or even units. Remember, a unit describes what a number is. So, like time has units of like hours or minutes or seconds because those units express time, whereas a unit such as centimeters, inches, feet, meters describe distance. So, we're going to use a unit of distance here, and one of the common units, of course, is the meter, which is roughly 3 feet in physics. So let's put our numbers and units down. Okay, so we kind of conveniently placed the dog at 0 meters. And we're going to say the position of the dog, X. So we're going to use X for position, because think about left and right as the X direction. So the dog is at 0 meters. Okay, now instead of moving the dog, let's say the dog is kind of stay in place, and we're going to be moving the number line. So instead of saying the dog starts at 0, we can move the numbers like so. Now the dog is at 2 meters. The dog didn't move. We actually just redefined the starting position of the dog as 2 meters. So let's say the starting position of the dog is X equals 2 meters. Or we can even do this. The dog is now at a starting position of X equals -1 meters. So here's the thing. We can define the starting point anywhere we want. So something does a dog, a person, or whatever, and the starting point does not have to be 0 meters. I mean, a lot of times we may use that, but it doesn't have to be. Also, take a look at the symbol right here. This is the origin symbol. So that origin symbol defines which way the positions are positive and which way the positions are negative. So take a look. Positions going to the right, according to this origin symbol, are positive, and positions going to the left are negative, but only according to the direction of that origin symbol. Okay, so let's talk about another term we have in physics. So position is where an object is, but something like what we say displacement is how much the object changes its position by. So let's say the dog starts at position A and then moves to position B. Now, from point A to point B, the dog started at a position of 2 meters and then went to 6 meters. So what we would say is the change of position, the displacement, is 4 meters. Now, take a look at, this is a symbol you may or may not have seen before. This symbol is delta. That triangle means the change in. So the dog starts at 2 meters, that's the initial position. The final position, say, is 6 meters, and the change in position is 4 meters. Now, let's say the dog keeps going. So let's say the dog moved from point B to, say, point C. Okay, so from point A to point C, the dog still originally started, say, from 2 meters, went to -3 meters, and if you actually kind of count over, it's going to be 1, 2, 3, 4, 5. So the dog went -5 meters from his original starting position. Now, again, the positive and negative numbers are defined based on the direction of that origin symbol. So be careful. For now, we'll keep it in that direction, but later we can change the direction of that origin symbol, and it does change the negative and positive signs. Now, clock time. So let's say the dog is again at point A, and let's say we start a stopwatch at point A. So at position A, we start a stopwatch. So let's say The stopwatch starts at 0 seconds. You can kind of see that little clock logo there, so it's at 0 seconds. And let's say the dog moves to point B, just like before. Okay, so at point B, the dog is now at 6 meters. And let's say the dog really took his time. It took 15 seconds. So the clock time is now 15 seconds. So the clock is always running. And now let's say the dog now goes to point C. So point C is at -3 meters, and the clock has now reached 30 seconds. So clock time is not the difference in time between the points, but the total elapsed time. So the clock is like always running. So please review these terms, and I'll see you in the next video.